I will explain about the rank correlative coefficient in this video. As we explained in previous video, we can express the correlation using quantitative measures as product movement correlative coefficient and rank correlative coefficient. In the first one, Carr-Pearson's product movement correlative coefficient, it can be used when the correlated variables are in quantitative manner. Second one, Spearman's rank correlation coefficient can be used when the analysis uses the ranks of non-quantitative values in the case of correlated variables are in non-quantitative manner. We have discussed and calculated about the product movement correlative coefficient in the last video, and this video is about the rank correlative coefficient. Rank correlative coefficient. Relationship between ranked variables is evaluated using the rank correlative coefficient. The relationship between non-quantitative variables can be measured using the rank correlative coefficient. In order to evaluate the correlation between the qualitative variables such as intelligence, honesty, beauty, etc., rank correlative coefficient is used. There are a number of situations in the business field and also our day-to-day life where rank correlative coefficient is applicable. As an example from the business field, to study the agreement of the consumer attitude towards a product introduced to the market under various brand names, we can use rank correlative coefficient to measure the correlation between two variables. There are two different formulas to rank correlation coefficient when the problems with equal ranks and without equal ranks. First one is without equal ranks. We can use this formula. Here DI means difference of corresponding ranks and N means number of pairs of rank. Let's see a hypothetical example for this formula. Here, following table shows the final round marks given by judge and votes given by people for a competition to select friendliest supermarket in ABC province. Compute the rank correlative coefficient. I put the X for marks given by judge and put the Y for votes given by people. Before doing calculations, we have to rank both variables. It is easy to doing that by adding some additional columns to given data table. Here I added 2 columns for the table. As the first step, here I give the rank for first variable, which is marks given by judge. Normally we put ranks into descending order. Rank 1 for highest value, rank 2 for second highest value, and so on. Accordingly, highest value of X is 96, which corresponding to the supermarket J. So I put rank 1 against J. Second highest value of X variable is 93, corresponding to supermarket C. So the rank of that variable value is equals to 2. Likewise, I can complete all the ranks for X values. That means rank for marks given by judge. Here I completed the ranks for the marks of judges. As the second step, here we have to put the ranks for the variable Y. Here I give the rank for second variable, which is votes given by people. Here also I put the rank into descending order. So rank 1 goes to the supermarket C, which has highest votes from the people as 200. So I complete the rank for people's votes as shown in the table. Then we have to calculate difference between two ranks in each supermarket. Difference between two ranks related to supermarket A can be calculated 3 minus 3 equals to 0. For the supermarket B, 4 minus 7 equals to minus 3. Here 3 minus 3 equals to 0. Likewise, I completed that column, which means difference between the ranks. As the last column, we should find squared value of each value of difference between ranks. Here first value squared of 0 is 0. Then squared of minus 3 equals to plus 9 and so on. Then we should get the summation of last column, which indicate the squared value of difference between ranks. Here the summation is 34. Then it should apply to the formula. This is the formula when there are no equal ranks. As our calculations above, sigma d squared is 34 and n number of pairs equals to 10. I applied that value to the formula. Then simplify the values. After simplify up to this step, we can put final answer as fractions or decimal as you wish. If you put answer as fraction, you should remember that should in simplest value. Here. But if we put the final answer as decimal, it is easy to interpret the correlative coefficient. So I put as decimal value. As the correlative coefficient is equal to plus 0.812, there is strong positive correlation between people's vote and marks of judge. Let's see the situation with equal ranks. If dataset consists of equal ranks, we have to add correction factor to the formula. So the formula of rank correlative coefficient is change bit. But keep in mind, some institutes and also the people tend to use previous formula for this situation too. Although you have to use that according to your institutional preference, you should know this is the correct formula. So this is the formula when the data set with one or more equal ranks. Here, DI means difference of corresponding ranks, N is number of pairs of rank, M is number of pairs with equal rank. Let's see a hypothetical example for this situation. Following table shows the final round marks given by judge and votes given by people for a competition to select friendliest supermarket in ABC province. Compute the rank correlative coefficient. Here we can identify repeated values. As an example, judges' marks for supermarket B and F are equal, and marks for G, H and I are also same. For the case of votes, votes for D and F are equal, and also E and H are equal. So we have to rank accordingly and use the formula with corrected factor. First, I put the ranks for variable x which is marks of judge. As you can see, I put first 3 ranks for first 3 highest elements. Then fourth highest value 88 appears for 2 supermarkets. Normally it should be ranked 4 and 5. So we have to put midpoint of ranks against that supermarkets. Here 4 plus 5 equals to 9 and 9 divided to 2 equals 4.5. Therefore, I put 4.5 for supermarket B and F as their rank. As I explained, I put 4.5 against both supermarkets B and F as their rank for X variable. Up to this rank, we already put rank 1, 2, 3, 4 and 5. So then we have to put rank 6 for next highest. After I put the rank 6, 7, 6 and 7, there are 3 elements which has same value as 76. Normally we have to put ranks 8, 9 and 10 for those values. Since here these 3 elements are equal, I put the mid value for each. Let's see that rank 8 plus 9 plus 10 equals 27. Since there are 3 elements, I divide 27 by 3, which equals to 9. So I put the rank 9 for these 3 elements. Then we have to rank the variable y, which indicate votes of people. I put the rank 1, 2 and 3 against the highest values. Then there are 2 same values as 150 for supermarket D and F. Since there are 2 same values for supermarket D and F, we have to put midpoint of ranks against the same marks. Here 4 plus 5 equals to 9 and 9 divided to 2 equals 4.5. Therefore, I put 4.5 for supermarket D and F as their ranks of variable y. Likewise, I can complete this column. I completed the ranks for variable y, which indicate the votes given by people. Then we have to calculate the difference between 2 ranks. As next step, we have to calculate difference between 2 ranks in each supermarket. Difference between 2 ranks related to supermarket A can be calculated by 3 minus 3 equals to 0. For the supermarket B, 4.5 minus 7 equals to minus 2.5. Likewise, we can complete the column which indicate difference between 2 ranks. At last column, we should find squared value of each value of difference between ranks. Here first value squared of 0 is 0 and second value squared of minus 2.5 equals to 6.25 and so on. Then we should get the summation of last column which indicate the squared value of difference between ranks. Here the summation is 31. Then it should apply to the formula with correction factor. For the correction factor, we want to find observations with equal ranks separately. As I highlighted here, ranks for x, there are 2 times 4.5. So, first m value is 2. Then 3 times 9. So, second m value is 3. In the case of Y ranks, there are 2 times 4.5 ranks. So the third M value is 2. 2 times 8.5 ranks. So fourth M value is also 2. We have to use 2, 3, 2 and 2 as M values for correction factor of the formula. This is the formula with correction factor which used for the situations with repeated ranks. Then I applied data to formula. After simplify up to this step, it is good if we put answer with decimal value other than the fractions. So I put answer as this. As rank correlative coefficient equals to 0.79 plus 0.79, we can interpret there is strong positive correlation between votes of people and marks given by judge. Finally, let's see the properties of rank correlative coefficient. The rank correlative coefficient lays between values -1 to +1. If the rankings are perfectly agreed, the coefficient will be +1, whereas it will be -1 when the rankings are perfectly disagreed. Suppose all the ranks of people's votes totally equal with all ranks of marks of judges. That means judge's rank 1 is also people's rank 1 and judge's rank 2 is also people's rank 2 and so on. On that situation, it means the rankings are perfectly agreed. The coefficient will be +1. On the other hand, suppose all the ranks of people's votes and people's votes totally different with the ranks of marks of judges. That means judge's rank 1 is the people's last rank as 10. And the judge's rank 2 is the people's rank 9, which is before the last, and so on. On that situation, it means the rankings are perfectly disagreed. The coefficient will be -1. The third property, rank correlative coefficient is -1 when this situation. You can check this property if apply these values to formula. As usual, there are both merits and demerits too. By the side of merits, it can easy to understand. Rank correlative coefficient is easy to understand compared with the product movement correlative coefficient, and it is relatively easy to compute. And also it can use for qualitative variables. We can use both quantitative and qualitative situations in rank correlative coefficient. And there are no any assumptions for rank correlation. But we can't practice for binary variables. We can't practice rank correlative coefficient for binary variables, and we can't do it when the number of pairs of observation is exceeding 30. Evaluate the correlation is not practical using rank correlative coefficient. And also, rank correlative coefficient shows the linear relationship between ranks. Once only the ranks of two variables are available, the one and only technique to be appeared in evaluating the correlation between those variables is rank correlative coefficient. You have to remember that when the number of pairs of observations is exceeding 30, when all considerable information between the variables haven't been utilized, and when the data are available in group frequency distributions, applying the rank correlative coefficient to evaluate the correlation between such variables is not practical. As so far, I explained about the rank correlation analysis and how to calculate the rank correlation coefficient when the dataset has repeated or equal ranks and without equal ranks. Finally, I discussed about the features of rank correlative coefficient. In next video, I hope to explain how to get output for product movement correlative coefficient and rank correlative coefficient using statistical softwares.